Hello everyone, and welcome to the solutions over mini test. Hopefully this works. I am recording this on the iPad. Again, this may be completely scuffed, but we'll see. So, hopefully you took the mini test. Hopefully you didn't get stuck on any problems, but if you did, let's solve it together. Okay, so let's begin solving the test. For task 1, we had to identify numbers, and our first part of that task was, is -7 an integer? So, what did we learn they are? Integers are a set of numbers that include positive numbers, negative numbers, and zeros. However, they don't include fractions. -7 is a negative whole number and is not a fraction, which means it's an integer. We can take that off and say yes, it's an integer. Is 0.33333, repeating, rational? Yes, we did the proof in the video. You can write that in the forms of x equals x, and 3.3 is 10x. If you put this together as we did in the video, we get that 3 equals 9x, therefore x equals 1/3, which is a fraction. It's a repeatable decimal writing of the number, which means it's a rational number. Again, yes. Classify root of 5 as rational or irrational. We did the proof for square root of 2 in the video, but for the root of 5 we do the same thing. We write the assumption that it's p divided by q or a divided by b for this example. We will square the entire thing and put b to the left, so we got 5b squared equals a squared. The same rule applies. If a squared number can be divided by a prime number, then the normal number, so the a in this case, has to be divisible by 5 or that same prime number as well, meaning a can be written as 5k. So if we put these two together just like we did for the square root of 2, we get 5b squared equals 25k squared. We cut out 5 on each side again, and we get b squared equals 5k squared. And same rule applies here. b has to be divisible by 5, and since they're both divisible by a same number, that fraction is not already in the shortest form possible, which means that square root of 5 has to be irrational. Now for task 2. Prime factorization and greatest common divisor and lowest common multiple. Prime factorize 84. I will clear the page so we get a bit more space. We write this down, we divide by 2, we get 42, by 2, 21, 7, 3, 3, 1. Therefore, 84 is 2 to the power of 2 times 3 times 7. And either of these two would be a sufficient result as long as you show that these are the prime factors of this number. Now find the greatest common divisor of 84 and 36. We do the same thing for 36. 2, we get 18, 2, we get 9, and 3 squared, so we simplify the process. So 36 is 2 squared, 3 squared, and as we know, the greatest common divisor is all of the common prime factors with the lowest exponent, which means 2 to the power of 2 and 3. We multiply that together, we get 2 to the power of 2 times 3 equals 12. Which is the answer for B. Now for the lowest common multiple of 12 and 20, we will do the same thing as we did for the greatest common divisor. We'll separate the primes of 20 and 12. We get 2, we get 6 and 10, 2 again on each, we get 3 and 5, which are the factors as well. And now we repeat the same thing. The lowest common multiple, we take all of the primes. Here it was 2 squared and 3, and on the right side was 2 squared and 5. We take 2 squared, 3 and 5, multiply that together, we get 4 times 3 times 5, which is 60. And the result of C task is 60. Now let's move to the task number 3. Hopefully everything was clear. There was no other issues. If you do, please comment down below and I'll try to explain a bit more into detail. I'm just keeping this short and compact. As for task 3, we have to use properties and order operations. For first, we have to apply the distributive property in this bracket, as we know, by the rule of a times bracket of b plus c, it works as a 8b plus ac. And if we do the same thing here, we get 5 times 2 plus 5 times 6. And we can also solve for that, which gives us 10 plus 30, which is 40. Now, for b, we have to simplify 3 squared plus 4 divided by 2. So, according to PEMDAS, we would solve first the brackets, which means that we have to first solve for 3 squared plus 4, which is 3 times 3 is 9, plus 4 is 13. Now, we go to division. 13 divided by 2, we can either leave it as a fraction, or we can solve it as a 6.5. Either of these would work, but I think most teachers would prefer a fraction instead of a general result, unless they specify to calculate the result to solve the fraction. Next up, we have the order of PEMDAS. And if we recall what it stands for parentheses or brackets, exponent, multiplication or division, and addition and subtraction. And what has the priority order by PEMDAS, addition or multiplication? I hope you had no problems answering this. Multiplication. Now we will dive into the proof of square root 2. What type of proof shows square root of 2 is irrational? Proof by contradiction, where you assume one thing and you have to prove yourself to be wrong on that assumption, so you find the proof by contradicting the original idea, hypothesis. So why can't both a and b be even in the proof? Well, we had to assume that the fraction of a over b has to be simplified to the lowest terms, meaning that their only common divisor is 1. And since we had to assume that, they can't both be even, because if they were, another common divisor they would have, it would be 2. And after that, we could simplify it further, which it goes against what we assumed, which is contradiction. And since the result contradicted our original idea, we proved that square root of 2 is irrational. Therefore, no, both of them cannot be even, because that's how we defined it at the start of the proof. What is the key contradiction in the proof? Well, first we defined a over b as having only 1 as their divisor, which means they are simplified to the lowest terms, as said before. And the problem is that through solving the equation of square root equals a over b, we got the result that a can be divided by 2, so it's an even number, and same for b. So both of them came out as even, which is a problem because they would both have to be divisible by 2 after we assume they're only divisible by 1. And that contradiction is what made the proof stand, what made us know that square root of 2 is irrational, and we can use the same thing for, as we did, square root of 5. I hope you all passed this mini test with perfect scores. If you didn't, that's also okay. We learn from our mistakes, hopefully, so we don't make them in the future again. I see you in the next video.